So now that we know about rational numbers, let's just give a quick recap saying that rational numbers are in the form of p over q, where p and q are both integers and q is not equal to 0. Okay. And some examples we quoted were such as 2 over 3, 5 over 6, and so on, correct? And we also know that all of these are rational numbers, but we also know that these are also fractions. So all fractions are also rational numbers. Okay. Now let us use this number line to show how we represent these rational numbers on a number line. It is pretty much the same concept as we have done in the fractions. Okay, so let's now look at 1 over 2. How do you show this number on a number line? So 1 over 2, as we know, this is half, right? Which is bigger than 0 but less than 1. So we know that this is 0 and this is 1. And if we create a point which is exactly in the middle of these two numbers, then this number can be pointed as 1/2. Now, if I were to make this as negative half, where would this be on a number line? So we know that on a number line, anything to the right of 0 is plus and anything to the left of 0 is negative. So negative half will exist between 0 and negative 1, correct? So if I were to create a midpoint between 0 and negative 1, and this number will be negative 1 over 2. So this is how we show these numbers or the fractions or the rationals on a number line. Let us put one more number on a number line, 3 over 2. Okay, this is plus. So 3 over 2, if you convert the ratio, it becomes 1.5, which means it is bigger than 1 but less than 2. And if you create a midpoint between 1 and 2, it is 1.5, or it is also written as 3 over 2 in the positive space. So this is how we show fractions or rationals on a number line. Okay. So let us talk about now equivalent rational number. Let's say I give you a number 1 over 2. Okay. And I give you another number, say 2 over 4 and 3 over 6. I am saying that all of these three things, all of these three numbers are equivalent to each other, because when you get rid of the common factors between numerator and denominator, each one of them becomes this value. There is nothing common between 1 and 2, so it will be as it is. But for 2 and 4, 2 divides 4, correct? So 2 will cancel, it becomes 1, and 4 cancels. When you divide 4 with 2, it becomes 2. So this is 1 over 2, which is exactly this value, correct? So these two values are equivalent, right? And likewise, if you divide 6 with 3, then it can be written as 3 divides with 3, it becomes 1. 6 divides with 3, it becomes 2. So this also becomes 2, 1 over 2, right? So based on this mathematics that we just did here, we say that 1 over 2 is the same thing as 2 over 4, which is the same thing as 3 over 6. Or in other words, all of these are equivalent rational numbers. Okay? Exactly the same concept what we studied in fractions, nothing different. So we keep applying the same fundamentals all over again, right? Let us now say that you have been given a rational number which is 5 over 8. And if I were to create an equivalent rational number, what I do is I multiply and divide this rational number, both numerator and denominator, with the same integer both places. So if I multiply this with 2, both numerator and denominator, it becomes 10 over 16, which is an equivalent rational number, right? They both are equivalent to each other. Hence, this is how you create equivalent rational numbers. So once again, it is exactly the same concept as we have studied in fractions. Now, this would lead to another important concept, which we also studied in fractions, but it is worthwhile studying here. Let's say you have a rational number 20 over 24. Okay. Now, I'm going to get rid of all the common factors between these two numbers, 20 and 24. It's a rational number, but there are a lot of common factors. Okay. So let's see how 20 expands by their prime factors division. So 20 is 2 times 2 times 5, a product of 3 prime numbers, right? And 24 is 2 times 2 times 2 times 3. 2 times 2 is 4, times 2 is 8, times 3 is 24, correct? A product of prime numbers is what we need both for the numerator and the denominator, right? Now let's get rid of the common factors. 2 cancels 2, this 2 cancels 2, and finally you are left with 5 over 6. Now you realize that there is nothing common between 5 and 6. So this rational number that was 20 over 24 has been reduced down to 5 over 6, right? And it cannot be reduced any further. So when a rational number is in its lowest form, it is called the standard form of a rational. Okay, do you remember this concept in fractions? Yes, because we studied exactly the same thing. We said that when a fraction is down to its lowest possible value such that there is nothing common between a numerator and denominator, then it is called the lowest form of a fraction. And here we are calling as the standard form of a rational. These two are identical things. The mathematical concept is exactly the same, but we need to know this terminology. All right. Now let us go for learning about operations on rational numbers in our next video.